And so I think one of the questions that I was really interested, or in fact amazed to know, was how did the Himalayas come into existence?
Yeah, I would love to visit. The Himalaya are really the great mountain range of the entire Cenozoic era, and have been growing over the last about 55 million years as India, which was a separate continent, has been drawn through the process of subduction beneath Asia. So subduction, I should just briefly say, is the signature process of tectonics on Earth, by which ocean crust, which is created at mid-ocean ridges like the Mid-Atlantic Ridge, of which Iceland is the only part that emerges above the sea. So that ocean crust is new at the ridges, and then it cools and contracts and becomes dense enough ultimately to sink back into the mantle from which it came, in a beautiful recycling system. So the ocean crust is relatively short-lived and subducts back into the mantle. And in some cases, the ocean crust will be pulling behind it a continent. And that's what's happening in the case of the Himalaya range. India was a separate continent until about 55 million years ago, when it began to collide as the subducting plate that would be north of India and today now downing the mantle began to collide with Asia. And continental crust, which is much more buoyant, it's primarily made on average of granite, in contrast to the ocean crust, which is mostly the dense rock called basalt. Continental crust can't be subducted. So essentially in the Himalaya, you have two continents being stacked up on top of each other, and the crust is buckling and folding and essentially doubled in thickness. And so you've got this tremendous pile of continental crust, the highest anywhere on Earth. And in fact, as we look back in the geologic record, there haven't been too many Himalaya-like mountain belts. They're quite unusual. We can see one that formed about 1 billion years in North America, probably in the northern part of the Caledonian Appalachian mountain chain in the North Atlantic region in what is now Greenland and Norway. But these aren't very common. So they're unusual geologically because continents don't usually stack up like that. And of course, as you know, in India, they completely dictate the weather and the regional climate system. So they're more than a tectonic feature. They're also influencing hydrosphere and atmosphere processes. And even over a longer period of time, the Himalaya are probably the reason that the Cenozoic era, the last 65 million years since the dinosaur extinction event, the reason that the Earth globally has been cooling. And let me explain that. It's a little bit complicated, but the Himalaya are big enough mountains that they have influenced global climate. So the dinosaur time was a greenhouse planet time. It was very warm. There were probably no significant glaciers or ice caps anywhere in the world. Sea level was very high, probably 100 meters or more higher than today. And then as India and the Asian continent began to collide, huge amounts of rock would have been exposed to weathering. And when you weather continental crust, what you do is release a lot of calcium carbonate, or calcium, the element, which is then taken to the sea in solution by rivers. And it will eventually combine this calcium with carbon dioxide in the ocean and form limestone. And that process is essentially Earth's long-term way of sequestering carbon dioxide that's being exhaled by volcanoes and locking it away in the long term in mineral form as limestone. And when you have a great mountain range like the Himalaya, with lots of weathering and lots of new ions being constantly transported to the sea in this way, and it's a slow process, but over 55 million years, the Himalaya have cooled the planet down by sequestering carbon dioxide away in this mineral form. And we see this quite steady cooling over that long period of time. And it's largely attributed to the existence of this great mountain belt. Now, that process is still going on, but it's not able to keep up these days with the huge amounts of CO2 and other greenhouse gases that humans are putting into the atmosphere. So sadly, we can't count on the mountains to save us from our own emissions. But it is, I think, a fascinating thing that a tectonic process over long time scales has profound influence on the atmosphere and climate system.